Not really.
But you guys will need to memorize like what, 6 of your amino acids? 8. So which ones do you need to know?
You know, glycine.
Glycine, alpha, cysteine,
Hi, guys. Right, cysteine, I've got okay, so here's the thing about amino acids that you guys need to recognize is all of them have the same backbone.
There you go. There you go.
Okay. They all have that backbone right there.
Oh, it's just because she does CO.
It depends on what pH you're at, whether that's a COO or whether this is an NH3. It depends on your pH.
Okay.
This would be at body. So this would be at the pH of your body, like 7.2. You'd have a negative charge, and that's what we're going to talk about here. Draw the structure on the pH. Okay, so the one thing you guys need to recognize is they all have that backbone. Every single amino acid in the entire world has the NCC backbone. Okay? What you need to memorize is what's coming off of that central carbon, what your R group is. That's what you need to know, is your R group. Okay, glycine, your R group is a hydrogen. Use your most simple amino acid. There's glycine. That's your most simple. It's got a hydrogen. Okay? Okay, alanine is your next most simple, which means it's got a carbon, but only one carbon. So it's a CH3, it's a methyl group. So alanine is a methyl group.
Let's finish this one.
So what do you think phenylalanine might be? Maybe alanine with a phenyl group on him? Woo. So alanine, but I have to take a hydrogen off, right, in order to put another bond on him. So CH2 with a phenyl group, phenylalanine. So you say CH2 phenyl. Phenyl. Serine is a CH2 with an alcohol group on it. So serine is a CH2OH. Cysteine is a CH2SH. The thiol group on it. Okay, so he would be an SH right there. Tyrosine, I'm going to have to look at because I honestly don't know what tyrosine is.
Alcohol.
Oh, that's right, he's got the phenyl group with the OH, so he's a phenol. Right? So he's got the phenyl group with an OH. Okay, so tyrosine is your CH2 phenyl. So he's like phenylalanine, but with an OH on it. So he's like a mix between phenylalanine and serine. Okay. Aspartic acid is an acid. He's got the CH2 carboxylic acid on him. So he's a CH2 carboxylic acid. And then your pH will tell you whether or not that hydrogen's on him. And then lysine is your, okay, so here's the thing I want you guys to recognize. So glycine's your most simple with just a hydrogen. Do you see how everyone else has one carbon? One carbon and then your functional group, right? Okay, lysine has 4 carbons and an amine. Yeah, 4 carbons and an nitrogen. Yep. So lysine has the 4 carbons. Everybody else, except for glycine, being your hydrogen, everybody else has a carbon, and then it's functional group. Okay? So that's what you need to know. So when you go to draw them, you go, okay, I know I have an NCC, that one's a carboxylic acid, that one's some hydrogens on him, that one's a hydrogen, and then whatever my R group is. That's what I do. Okay? Alright, so you guys need to know those. Memorize those. They're still flashcards. Okay, draw the structure for the amino acids that you're going to memorize. Oh, look at that. Okay, so now we gotta identify them as acidic, basic, or neutral. Okay, so rather than memorizing in the book whether they're under acidic, basic, or neutral, let's look at them. Okay. Wait, do they have polar neutral and non-polar neutral? What did she say here?
She said acidic, basic,
Polar or non-polar. Okay.
so nothing crazy.
Right. Okay. So what here do you think is acidic?
The ones with the OH.
Okay, OHs aren't acidic.
Yeah.
OHs are alcohols, right? The one with the carboxylic acid, right? So you guys don't need to know glutamic acid, but aspartic acid and glutamic acid are your two acidic ones.
This is just, yeah.
So draw the structure,
I already drew
and now acidic, basic, right? So your acid will be acidic, right? Your nitrogen, your amine, will be basic, right? Okay, so those are the two, the one acidic, one basic that you need to know. Okay, so are hydrogens polar? Is the carbon hydrogen non-polar? No, so it's non-polar. CH3, non-polar. All carbons hydrogen, non-polar. Ooh, I have an oxygen here, polar. Polar! Polar! Got an oxygen, polar. Right?
So we can just memorize that and then be good to go.
Well, you don't even need to memorize whether it's non-polar or polar, right? Because you guys know that. You guys know if there's an oxygen there, you're polar no matter what. That's how it's been all semester. If there's an oxygen or a nitrogen there, you're polar. In this case, nitrogens are basic, so we're not even worried about polar. Okay, so on this list that she gave you, what is that? Oh, acidic polar? Okay. Alright, acidic polar, because it is, because it's got oxygens, right? Polar because it's got nitrogens. Okay. So you guys okay with that? Alright, so we're done with one. Bam. Alright, so now, can I erase this? Everybody's got their pictures, everybody's got what they need. One more. Just in case. Alright, going once, going twice. Alright, so now, determining what they're going to be like in different pages. So we are looking at, okay, so we'll do aspartic acid first, so aspartate, right? So first I'm going to draw my NCC, NCC, NCC. This guy's carboxylic acid.
I knew it. It was perfect.
So I'm going to put these hydrogens like this, and then we'll decide about that hydrogen.
Oh my god.
Okay, so we're going to do aspartic acid first. Or they call it aspartate.
So we start at page 7.
Yep. Well, I'm going to go. I'm going to go 2, 7, and 12, just like that is. Okay. Okay, so From 2A, do you guys remember that acidic means that you have lots of hydrogen ions? Hydrogen is available to everybody. It's like Oprah. Everybody gets hydrogen, right? So at a low pH, everybody gets their extra hydrogens. Every. Okay, so my carboxylic acids get hydrogens. And my amine gets its third hydrogen. What? Yes, so he has a positive charge, because nitrogens, when they have 4 bonds, get positive charges on them. Okay, and I'm going to go ahead and we're going to talk about little charge on each of the above amino acids at each pH. The molecules migrate with a positive or negative. So we're going to do 2 and 3 together. And 4.
Yeah, they're all real close to each other.
Yeah, they're all pretty much. So basically on an exam, these will be the 3 things you'll have to answer with this. Okay? So what is my total charge of this one right here? +1, right? He's a +1. Because your oxygen, your carboxylic acids have hydrogen, so they're not negatively charged. Your nitrogen has an extra hydrogen, so he is positively charged. So my total charge on this is a +1. Okay, so at a pH of 2, everybody gets hydrogens. Everybody gets H. Okay? You get an H, and you get an H, and you get an H. Okay, at a pH of 7, which is neutral, I don't have as many hydrogens available, right? And acids love to give up hydrogens. That's what acids do, right? They give up hydrogens. So at a pH of 7, my acids will give up their hydrogens, but my nitrogen will not. So at a pH of 7, my carboxylic acids do not have their hydrogens, but my nitrogen has his extra hydrogen. So at a pH of 7, nitrogens get hydrogen. The carboxylic acids do not get hydrogens. Does that make sense? Because acids love to give up hydrogens. So at a neutral pH, somebody's got to give up their hydrogens. It's the acids that will give up the hydrogens. The amine's still going to keep his hydrogen as long as he can. Okay? At a pH of 12, I'm at a really high pH, which means there's not many hydrogens available. Nobody gets hydrogens. I mean the extra hydrogens. Of course, these guys all still have those hydrogens. That's just never a question. They always have their hydrogens. Right? But all we're looking at is the nitrogens and the carboxylic acids. So no, no, and no. That amine does not get his hydrogen either. Okay, so my total charge on this guy at a pH of 7 is -1. My charge for this guy, -2. Okay, so that was, what is the overall charge on each of the above amino acids at each
How
pH?
many hydrogens to take away when it's pH 7?
At pH 7, your nitrogens get their hydrogens, your carboxylic acids do not.
Okay.
So carbox does not.
Okay.
Only your nitrogens get a hydrogen at a pH of 7. At a pH of 12, nobody gets extra hydrogens.
Okay.
Okay, and you understand what I mean by that? These hydrogens are always here. You're never going to take those hydrogens off. All we're ever looking at is the nitrogen on the main chain, the carboxylic acid on the main chain, and if there's a nitrogen or carboxylic acid here, we pay attention to that. Right, so we'll go ahead and we'll do the others too. Okay? Does that make sense? Okay, so now number 4 is, what is the isoelectric point? Isoelectric point is when your total charge equals 0.
That's what I thought.
When your total charge equals 0. So what pH will the total charge be 0 here?
Between 2 and 7?
Between 2 and 7, right? So you're not going to say between 2 and 7. You have to give it a number.
Oh, yeah?
Yes. So
How do you know?
3, 4, 5, 6. Right? I would say it's 4.5. 4.5. Right in the middle of those.
Okay.
You guys see what I did there? Right? I didn't think so. Okay, so I'm saying, okay, do you agree with me? I'll be a charge of 0 right between these two. Right between these two, right? So right between the pH of 2 and the pH of 7. So I'm gonna go, okay, well if my pH, let me do this in green. I want to go right to the middle. So if I write down 2, 3, 4, 5, 6, 7, right in the middle of that is 4.5. So isoelectric here is 4.5. This is the second part of 3. Oh, okay. So, okay. Okay, opposites attract. Negative goes to the positive, positive goes to the negative, right? Okay, so for number 2, 3, I mean, okay.
What is the
Isoelectric point is pH equals 4.5. So basically what it is that pH at 4.5, these will turn solid. They turn solid at the isoelectric. Which kind of makes sense as to why our blood pH is so important, because if our blood pH gets off, we can make all of our amino acids float in our blood suddenly go solid. That would be bad, wouldn't it? Another color. Orange. I don't know if orange shows up very well. I love orange. It's my favorite color. I like Home Depot orange. I love that color. That's awesome. Okay, so will it migrate toward the, does it say positive or negative? So if he's positive, so he'll migrate to the negative electrode. Negative, so he'll migrate to the positive electrode.
Oh, thank you.
Negative, so he'll migrate to the positive electrode. And the electrophoresis. I'm assuming she means that means pH.
Yeah, just like.
Okay, so there was aspartic acid, right?
Right, to be sure.
You guys got your pictures?
Okay, so you get.
Get your picture.
Let's make sure if it's actually for what we're trying to do.
Okay.
12-hour day.
So now,
11th hour.
I'm on my 11th hour. All right, so now I'm going to erase these.
I'm done with it.
You're done with it. So you find it. Right, so what do we do now? What's the next step? Right? We're gonna do this. Yeah, exactly. It's and you begin with the N. You begin with the bear.
Okay, so
So we find the two of these. So N minus.
oh, these are no longer true either.
No plus. No plus.
All right, so you got your NCC backbone drawn.
Yes.
So you want to draw your 3 NCC backbones.
So you always start off with 2 hydrogens on the end?
Yeah, your nitrogen always has 2 hydrogens. You're making a decision as to get his 3rd hydrogen or not. But he always has 2. Okay, so now we're doing serine, right? And serine's your alcohol. So serine is going to have a CH2OH. 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 Okay? So on this one, we don't care about our backbone. It's not a nitrogen or a carboxylic acid. I mean, about our group. It's not a nitrogen or carboxylic acid. We don't care. It's not going to gain or lose electron hydrogens. It's going to stay as is. Because all we ever care about with these is your carboxylic acids and your amines. Okay, so the pH of 2, everybody gets their hydrogens, right? So that means nitrogen gets his extra hydrogen, so he has a positive charge, right? Because nitrogen with 4 bonds is a positive charge. Carboxylic acid gets its hydrogen, so no charge.
This is a negative sign.
So what's my total charge on this guy? Plus 1. Awesome.
And
So now at a pH of 7, nitrogens get hydrogens, but carboxylic acids do not. So your nitrogen gets its extra hydrogen and has a positive charge. Your carboxylic acid does not get a hydrogen, so he's negatively charged. So my charge at that point is 0, right?
you tell me now.
So guess what his isoelectric is?
Negative.
7. Right? So here at a pH of 12, nobody gets hydrogens, right? Oh, because your isoelectric point is when your charge is 0. Okay, so isoelectric point.
It's also when you're solid and then also.
Well, you will turn a solid at that point, but the way that you know, because we're not going to tell you if he's solid or not. What we're going to say is what's his isoelectric point? 0 charge. Your total
Migrate both ways or no?
You won't migrate at all.
Happy medium.
Okay, so here at a pH of 12, nobody gets the hydrogens, right? So nitrogen does not get an extra. Carboxylic acid does not get one, so he's negative charge, right?
3 times 1.
So he's a negative 1, isn't he? Right?
So happy I can do that.
Yay! So now for his and I want to make sure that makes sense to everybody, what we're doing there. Everybody's good? Right, so his isoelectric is pH of 7, right? That's where he equals 0. Okay.
Which was isolation 7.
His pH equals 7. So it's not just 7, it's pH equals 7.
Because she just wrote like, I just like pH 7. It has to be pH equals 7.
She just gave us a really small line to write this on, so.
Well, because at a pH of 6.9, he's slightly, some of them will be positively charged.
Right.
At a pH of 7.1, some of them will be negatively charged. So a pH of exactly 7 is his isoelectric point. Okay, so this guy, at a pH of 2, he's going to migrate toward which electrode? The negative electrode, right? Because opposites attract. This one that's negatively charged will migrate to the positive electrode, and this one will not migrate. No, migrate. Right? Because he's a 0 charge, he will not migrate. Will migrate. Won't move at all. Right, get that picture. I'll do the other one. But I'll be with you girls in a second. Alright? Everybody's got their pictures? Sweet. So, good.
So it would be positive. So 28, right? So 2 ppb.
Alright, so now we're doing lysine, right? So everybody get their NCC backbone is going on. And lysine is the one that has the CH2, 4 of them, and the N, H, H, because nitrogen always has 2 hydrogens. We're deciding on the 3rd hydrogen. CH2, 4 of them, N, H, H, CH2, 4 of them. Right, you guys all got them drawn? Alright, so the pH of 2, everybody gets their hydrogens, right? So your carboxylic acid gets its hydrogen and has no charge. Your nitrogens both get hydrogens and now have charges, right?
Yes.
So what's my total charge on this guy at a pH of 2?
Plus 2.
Plus 2.
So why when you put it on the negative charge?
Which, Carboxylic acid, do you ever give carboxylic acid to charge if he has this
When
hydrogen?
it's a
No.
Oh, it's only for something negative, okay.
Right, right, this is hydrogen bonding, take him off and now he's ionic. Yep, yeah, carboxylic acid's only going to charge if they don't have the hydrogen. Alright, so at a pH of 7, my nitrogens get their hydrogens, but my carboxylic acid does not, right? So that nitrogen gets a hydrogen, he's a +1, right? That nitrogen gets a hydrogen and he's a +1. Carboxylic acid does not get a hydrogen, so he's a -1. Does that make sense? What's his total charge? +1. Awesome. So then at a pH of 12, nobody gets the hydrogens, right? So nitrogens do not have a charge because they've got 3 bonds. Carboxylic acid has a negative charge because he doesn't have his hydrogens. So what's his total charge?
-1.
So what's my isoelectric point of this guy? Between 7 and 12, right? So if we said 7, 8, 9, 10, 11, 12, right? Right between 9 and 10, so 9.5. So this guy will migrate at a pH of 2 to the negative electrode, right? Migrate at +1 to the negative electrode. And -1 will migrate to the positive electrode. Good times, right? Those aren't so bad, right?
No,
Your biggest thing is to remember, pH of 2, everybody gets hydrogens. pH of 7, only your nitrogens. pH of 12, nobody.
Yeah, that's gonna be important.
It's gonna be really important. Okay, I'm gonna pop over to these guys real quick and then I'll come back. Oh, I bet you guys can figure out how peptide bond is formed. I'm gonna try to get a picture of it. Maybe.
Oh my God, am I right?
Right, so I'll just draw this up here real quick. By the way, if you guys wanted to picture that, it's still on the back of this board. I didn't erase it. Right, so you have an N, C, C, and an N, C, C. Right, carboxylic acid. And I'm just going to put R here because your R group doesn't have any effect on these whatsoever. So I'm going to do this. So we're talking about just basically, I'm not worried about what the pH is at this point. I don't know what my R group is. What's the reaction between an amine and a carboxylic acid? Take out H2O, bond a carbon and a nitrogen together. That's how we make proteins out of amino acids, is by taking a bunch of proteins, amino acids together into a protein chain. All right, welcome back. Works. All right, girls, what are we doing? One more question. But have a positive charge.
Okay. I just wasn't sure about
This
that.
carboxylic acid on the end is not going to have its nitrogen and will have a negative charge. Okay. So your second C in each one of these has a hydrogen and your other C has a double bond oxygen. Hydrogen, double bond oxygen, hydrogen, double bond oxygen, hydrogen, double bond oxygen, hydrogen, double bond oxygen. Right? Your nitrogens, they're trans, so your hydrogen down, hydrogen down, hydrogen down, hydrogen down. Okay? So there's your backbone. So we've got our entire backbone. So now we need to draw our side chains. So we need serine first. Serine is your C, everybody's got a C, right? Except for glycine. And here's your OH. Serine's your alcohol. Okay. Cysteine is your SH, is your thiol. So cysteine is a CH2 with an SH on it. Okay. Then we've got aspartic acid. So a CH2 with a carboxylic acid on him, that carboxylic acid does not get his hydrogen, so he has a negative charge. Phenylalanine, so a CH2 with a phenyl group on him. Phenyl. And lysine, which is your base, so he's the CH2, 4 of them, with the nitrogen, and nitrogens at body pH get 3 hydrogens, so he's got his positive charge on him like that. Yep. So what's my net charge on this thing?
0.
0.
Oh.
Because I have a positive and a negative, and a positive and a negative. So I guess this protein would be at his isoelectric point. Does that make sense to you guys, how I did that?
Why do you have the charges?
Because we typically draw these at a pH of 7, because the body pH is around 7, right? And at a pH of 7, your nitrogens get their hydrogens, but your carboxylic acids do not. Right? And we never give the nitrogens in the middle of the chain extra hydrogens. They don't get extra hydrogen. You don't get charges on them.
Yeah, it wouldn't be a sit or trans bond if it was.
Right, exactly. Yep. So it's only your N's that get charges and your R groups. All right, sweet. So that's number 6.
These are all part of number 6.
Oh, which amino acid R groups might form disulfide bonds?
The thiol group.
Right. The one with the sulfur would form disulfide bonds, right?
So we'll just write this.
Yep.
That's what I said. I wasn't sure what we were doing.
So he'll do disulfide bonds, right? Which amino acid might form hydrogen bonds?
Serine.
So serine. Anybody else? Lysine. Right? Because you've got hydrogens on a nitrogen, right?
Okay.
Yeah, because that oxygen doesn't have hydrogens.
Okay.
And we don't really count the main chain, the backbone. We don't really look at that. We only look at the side, because that's why she says R groups,
Right.
just your R groups. So D, which might form ionic interactions. The charged groups, right? Anything charged is going to be ionic. And honestly, this nitrogen is probably going to form an ionic bond before it forms the hydrogen bond, but it's capable of both. Right, so which one's going to be hydrophobic? The ones that are non-polar, right?
Yes.
Phenylalanine. B.
So ionic is just like.
Ionic is charged. Anything that has a charged R group will be ionic.
In this example, just this end group would be ionic.
This one's got 2. He's got a negative charge on it. No, that's a backbone. We don't count the backbone. We're only counting R groups. Yep.
Okay.
Hydrophobic interactions. All right, complete the following. Oh, yay. I wondered if we were going to get to this today. Okay. All right, let me grab a piece of paper. Piece of paper is going to be the easiest thing for me to explain this part of this. Okay, we're going to do the beta pleated sheet. I can't do the alpha helix because I can't make an alpha helix out of a piece of paper. Okay, so.
Like we're not gonna do alpha at all.
We'll talk about the alpha. I just can't give you.
Oh, you just can't show us
I just can't give you the visual.
do a show.
Can't do a show. Right? Okay, so description of the structure for primary is just a straight chain. Just a straight chain of amino acids. AAs, amino acids.
Yeah, will she let us put AAs on things? Like,
Probably.
okay, cool, because I don't like writing all out.
Okay, so that'd be like a chain of amino acids. My backbone of amino acids. That right there is my primary structure. Okay, just my chain of amino acids. And I'm going to, my book.
What a book.
My books are
heavy.
I know, right? Oh, Amy has a book out. You got your book out. Sheesh,
And they're just hiding.
they're all hiding. There's not a lot of papers here. Right? So we go to the protein chapter.
Where's Amy to go? She blows up. She puts her back down.
Yeah, when I was in college, we did a, it was a fundraiser. We made t-shirts about the top 10 reasons to be a chemistry major. And then we had all the chemistry students put in their views and then we went through them. And, one of the top 10 reasons was you don't have to work out, have to carry the backpack with you all day.
Yeah.
Because back in my day, we didn't have computers and stuff, so we had books.
Lots of books.
Lots of books. Okay, so this would be like your primary structure.
Yes.
Just like a chain of beads of amino acids. There's your primary structure, just a chain of amino acids. On page 710, 711. Okay, so it's just your main chain. It's just a chain of amino acids. Okay, so that's your primary structure. Let's see, so which type of interactions in your main maintain the shape? It's your peptide bonds. Right? Those amide bonds are what maintains that shape, your peptide bonds. Peptide bonds, and what does she say between what groups?
Like what functional group?
Right, so between your nitrogens, I guess your amine and your carboxylic acid? That's what she's looking for there?
Like carbon to nitrogen or the carboxyl.
Yeah, I'd say your amine and carboxyl main chain. Backbone, main backbone, I guess. All right, so your secondary structure is, I'll go here first. So the type of interactions that maintain the shape in your secondary structure is hydrogen bonding. And it's hydrogen bonding between the nitrogen in the backbone, the hydrogen on the nitrogen in the backbone. So the hydrogen on the nitrogen in the backbone. And the oxygen, the carboxyl oxygen in the backbone. Okay, so far we haven't involved the R groups at all. So basically what it is it's the hydrogen on your nitrogen. So the hydrogen on your nitrogen will hydrogen bond with the lone pairs on the oxygen on your carboxyl group several amino acids away. So the hydrogens on the nitrogen in the backbone, hydrogen bonding with the lone pairs on the oxygens of the carboxyl group in the backbone. R group's not involved. So, here's my main chain. Okay? If a hydrogen over here on this nitrogen is maybe attracted to a lone pair on an oxygen over here, I'm going to do a folding, and I'm going to get my beta-weighted sheet. Right? Because my hydrogen over here on the end may be attracted to the oxygen on a carboxyl group over here, so they hydrogen bond, forcing that fold to happen. Okay? R groups are still sticking out the top and the bottom. The R groups haven't been involved in anything yet. Okay, so let's see. So description of structure is either your beta pleat or your alpha helix. Okay, here's the thing. If it's the hydrogen attracted to the oxygen 4 amino acids away, it will be an alpha helix. If it's more than 4 amino acids away, it will be a beta pleated sheet.
One more time.
If the hydrogen on the nitrogen is attracted to the oxygen on a carbonyl 4 amino acids away, it will be an alpha helix bend. If it's more than 4 away, it will be a beta pleated sheet. So I'm going to come across and show you what I mean. Okay, so see this carbonyl here? 1, 2, 3, 4 away, that nitrogen. attracted to that oxygen, 1, 2, 3, 4 amino acids away. That's page 715. See my carbonyl here? Attracted to that hydrogen, 1, 2, 3, 4 amino acids away. 4 carbonyls away. 1, 2, 3, 4 away. That guy. Okay. Yep. Right, so I've got, see how this carbonyl is attracted to that hydrogen? 1, 2, 3, 4 amino acids away.
You count C's.
Mhm.
1, 2, 3,
1, 2,
Oh, you count.
so I count the ones, 1, 2, 3, 4. Right, and then I've got 1, 2, 3, 4. That one attracted to that one. Right, that's my first one. Right, and then if that's my first one, 1, and it doesn't show all the carbons in here. Okay, but if it's 4 away, it's an alpha helix. If it is more than 4 away or whatever, so see how that's my nitrogen. Wait, that's my hydrogen on my nitrogen. That's an oxygen. Maybe the depleted sheet is caused by, maybe it's this hydrogen attracted to that oxygen. A long ways away in the chain, right? Maybe that one's attracted to that one. So it's gonna force that pleat. So basically, if we're looking at this beta pleated sheet, okay, so if we were looking at this necklace right here, right, maybe that one is attracted to that one. See how many amino acids away that is? So that's gonna force a beta pleated sheet. So basically what it is the hydrogen on this one is attracted to the oxygen over here, so it forces that bit. Okay? Okay, so that's secondary. That's your secondary structure. Alpha helix or beta pleated sheet. All your R groups are still sticking up off the top and off the bottom. If we are looking at above and below, okay, so this is where we're looking at the 4 away. Here's beta pleated sheet. So see how this one hydrogen attracted to an oxygen like way a long ways away. Okay, do you see how your R groups are still sticking off the top and the bottom? These green ones are your R groups. They're not involved in an interaction yet. See, these green ones are your R groups. See how they're just sticking off the top and the bottom? Yep. So they're not involved yet in any interactions. So, guess what groups might be involved in your tertiary? Probably your R groups.
Knew it.
Okay, so R groups are sticking up off the top and the bottom. Okay? So let's say that I have a serine over here that can hydrogen bond, and a lysine over here that can hydrogen bond. And this hydrogen on this serine, my OH, is attracted to the nitrogen maybe over here on the lysine. So that R group attracted to this R group over here. Whoop. Where I get my folding. So I get a globular protein, okay? All of the non-polar stuff is going to ooze to the inside of that. Okay, so when that folding happens, I've got this R group over here attracted to this R group over here. Folding happens, all my non-polar is going to go to the inside, while my polar is going to be out here on the outside. Okay? So, description of structure.
That sounds like boom.
Boom! It's like a
Overall folding of entire protein. Globular protein.
it's a globular protein, so I'm not sure what she's looking for in
That's what she kept saying.
description.
She said all of the words will
Globular?
have glob in them. Okay.
So,
Or globe or something.
globular.
Globin, stuff like that.
Okay, so what types of interactions? Well, my side chains, I can have hydrogen bonding, right? My R groups can hydrogen bond, some of them, right?
So this is like we're making amino
No, we're making
Oh,
making
protein.
It's protein.
It has to
Sorry.
accept the amino
making a
acids.
protein.
Out of the amino acids.
But what's happening is you're just like adding a bunch of amino acids to get your protein.
So your straight chain of amino acids is all of the amino acids that will be there. So say my protein needs
Okay.
1,960 amino acids. All those 1,960 amino acids will be in that straight chain primary structure. And then the hydrogens off the nitrogens in the main chain will be attracted to oxygens in the main chain, and you'll get that beta pleated sheet or alpha helix folding. Okay? All of those 1,960 amino acids are still there.
Yeah.
They're just folding.
Yeah.
Then my R groups will be attracted to each other and do some more folding into this globular shape.
Yeah.
Right? That's your tertiary structure.
Oh my god, is the next one fibrous?
What's that?
Is the next one fibrous?
So they
No,
just
it's
keep
quaternary.
No,
So
we
they
don't
just-
learn about how fibers.
We just
Oh,
keep
really?
folding and folding.
We just keep folding and folding until we make what protein we need.
Right.
And these are, we're talking about enzymes here.
Yeah.
Enzymes are globular proteins. Our muscles are fibrous proteins. Our muscles don't fold like this.
Okay.
Okay, these are globular proteins. Globular
So,
proteins are
Would the
enzymes.
end product be an enzyme?
Probably.
Like you could make an enzyme from this process?
So your R groups. What types of bonds can your R groups form? They can form hydrogen bonds. They can form disulfide bonds.
Oh god, they can do that.
Right? They can form ionic bonds.
Oh, geez.
They can form polar bonds, right? They can form hydrophobic bonds, right?
No peptide bonds?
Your peptide bonds in your main chain.
Oh, yeah.
All right, we already got rid of our peptide bonds. Okay. So what do you guys think a tertiary structure? I mean, a quaternary structure might be.
Is all of them just done?
Look, I got another tertiary structure, and my R groups that haven't interacted on this
Oh,
one
it's a
and
bunch
this
of
one.
tertiaries together.
More than one tertiary put
So
together,
that-
attracted by their
that-
R groups.
So now there's more amino acids.
Now there's more amino acids, exactly. So my tertiary structure is one blob, a quaternary structure is two or more blobs. Okay? This would be myoglobin. If you had 4 of these, it would be hemoglobin. Hemoglobin has 4 tertiary structures in it. So your quaternary is also globular. Oop, wrong color. So globular, 2 or more tertiary structures together. Okay, so that's the big thing. You have to have 2 or more tertiary structures to have a quaternary structure. If you only have 1, it's just a tertiary structure.
So then it can go through all the same
Same
bonds?
thing, because it's R groups. Everything your R groups can do. So hydrogen bonding, disulfide bonding, ionic, polar, hydrophobic. And you guys are going to learn when it comes to sickle cell anemia. Sickle cell anemia has a
Mutated bond?
It's a mutated, it's basically instead of, has a valine, which is non-polar, instead of glutamic acid, which is a carboxylic acid, which is polar, ionic. So if it has a valine instead, it wants to be on the inside, hydrophobic, away from water. Glutamic acid loves water. So replace that one glutamic acid amino acid in your blood cell with a valine, and suddenly you have sickle cell anemia. And instead of your blood cells being shaped like this, your blood cells are shaped like this, because that valine is trying to get the hell away from the water.
Interesting.
Yep. You guys are going to learn about that. That's actually going to be one of your
She
questions.
touched on it today.
We're probably going to talk about that on this exam, most likely. Why is this, like, why that happens? What's that? There it is. One amino acid change, one thing different, and suddenly you've got a disease. Crazy, isn't it?
Isn't
Yeah.
sickle cell anemia like super popular in areas with malaria? Because it like keeps them from getting it?
Yeah, sickle cell anemia actually, you're immune to
Substitution.
malaria.
Yeah.
You're immune to malaria. Basically, malaria can't affect your blood cells if you have sickle cell anemia.
Oh, why did I know that?
I don't know. You probably learned that in business, I guess. Or possibly micro. Okay, so give the main features of an alpha helix. What are the main features of the depleted sheet?
Oh, yes.
I'm going to come back to that one. I actually want for you guys to look in your notes, because alpha helix, right, like a phone cord, each of the helix contains 3 to 6 amino acids, so I'm sure this is what she's looking for. The helix and then the beta pleated sheet is probably the next page.
Yep, there it is.
Alright, beta sheets.
What page is that?
We're gonna, I will do that.
Okay, do you remember,
Oh, we've got 10 minutes. But I'll go upstairs along because you're going.
Supercharged.
All right, what are we doing now, girls? We haven't. Oh, wait, we need to take this off. Okay. The thing about colligative properties is it's all about the concentration of particles in solution. We don't care what the particles are.
It does look sunnier.
What are you doing?
But like,
Right.
It's supposed to be sunny tomorrow.
Okay, higher vapor pressure, so water.
He's in supervised right now, I'm worried. He's in supervised at Home Depot and Trader Joe's.
Okay. Okay, so basically what it is we're going to determine this by what we call osmolarity. Osmolarity is the concentration of particles in a solution. And osmolarity is your molarity times your number of particles, which is the same as ions. Okay? So water is just pure water. It doesn't have a concentration, right? So it's zero. The osmolarity of water is zero.
3.6 amino acids.
Because it doesn't have any particles in it, it's just water. Particles are things, like if you dissolve something in water, then you put ions into the water, right? If you dissolve sodium chloride in the water, you get sodium ions and chloride ions. So you have particles in that water. Sure, tap water has particles in it. And we're talking, when we're talking pure water, we're talking just straight up nothing in it. Yeah. Yep. Okay, so now calcium bromide, is he soluble? How do you know? Calcium is not soluble with everything. Wait, no, they're not in group one. So how do you tell?